Okay, this is question 8b from the 2013 Euclid. So the question is, log of base 2 of 2 to the power of x minus 1 plus 3 to the power of x plus 1 equals 2x minus log base 2 of 3 to the power of x, and x is an element of the set of real numbers. Okay, so the first thing I want to do is I want to put both logs on one side, and I'm just going to do that using the properties of log. So I can say log base 2 of 2 to the power of x minus 1 plus 3 to the power of x plus 1 plus log base 2 of 3 to the power of x equals 2x. So I just added this log to both sides. Now, using a log property, if I have two logs of the same base added to each other, that's going to be the same as me multiplying the insides of the log. So I'll show you what I mean by that. That is log base 2 of 2 to the power of x minus 1 plus 3 to the power of x plus 1 times 3 to the power of x, I'll just put that all in brackets, equals 2x. Now I'm going to use another property of log here, which says if I have log base anything of this equals this, I can just move the base over to this side, and this will become the exponent on it. So that will become 2 to the power of x minus 1 plus 3 to the power of x plus 1 times 3 to the power of x equals 2 to the power of 2x. So the base of this log became the exponent. The base here became the base underneath this 2 to the power of x, and 2x became the exponent. Now I'm just going to multiply out my left-hand side. Also, I don't like having 2 to the power of x minus 1 or 3 to the power of x plus 1. So another way to represent each of these using exponent properties is, so 2 to the power of x minus 1, that's the same as 2 to the power of negative 1 times 2 to the power of x. That's just using exponent properties because you add the exponents. And now I'm multiplying this by 3 to the power of x plus 3 to the power of x times 3 for this one times 3 to the power of x again equals 2 to the power of 2x. And I'm just going to move everything onto the left-hand side. I actually want to put this term in front. So I'm just going to say 3 times 3 to the power of x. And since I have 3 to the power of x times 3 to the power of x, I can write this as 3 to the power of x squared plus, now I want to write this term, 2 to the power of negative 1 times 2 to the power of x times 3 to the power of x. And then I subtracted this from both sides. So I'm going to get minus 2 to the power of 2x equals 0. And, okay. Notice that 2 to the power of 2x, this is actually the same as saying 2 to the power of x squared, because using exponent properties, when you multiply these, you get 2 to the power of 2x. Now, I want to let a equal 3 to the power of x and b equal 2 to the power of x. And this is just going to make the problem a little bit simpler. So I can rewrite this equation now as 3 times 3 to the power of x. I'm just going to write a squared plus 2 to the power of negative 1 times 2 to the power of x times 3 to the power of x. I just want to put my a first, so I'm going to write a. It doesn't matter since it's multiplication. 2 to the power of negative 1 times 2ab minus 2 to the power of x is just b squared equals 0. And I don't really like having this negative exponent here, so I just want to multiply both sides of the equation by 2. So I'm going to get 6a squared plus, so 2 times 2 inverse is just 1, so I'll get ab minus 2b squared, because I multiplied everything by 2, equals 0 times 2 is just 0. Okay, now I want to factor this. So I'm just going to use this little box technique to factor a quadratic like this. I'm not sure if you've ever seen this technique. So I'm just going to put the coefficient on the left-hand side of the box, and the coefficient on the right of the box, so 6 and negative 2. And now I want two numbers that multiply to negative 2, and I want them to be integers. So I'm going to try negative 1 and 2. And I also want two things that multiply to 6. So I'll try 2 and 3. So yeah, 2 times 3 equals 6. Negative 1 times 2 equals 2. And the idea with this is when you cross multiply these numbers and add them up, you should get the coefficient on the middle term. So 2 times 2 is 4 plus 3 times negative 1. So 4 minus 3 is 1. And that's the coefficient on the middle term. And now I'm selecting this top pair and the bottom pair. And so I just write this out like this. 2a minus b times 3a plus 2b equals 0. So this is just my pairs. 2a minus b, 3a plus 2b. Okay. Now, I just want to show you something here. So a equals 3 to the power of x, and this is always going to be greater than 0. And b equals 2 to the power of x, and this will also always be greater than 0 because anything, a positive number raised to an exponent will always be greater than 0. So 3a plus 2b, you can't have, so either 2a minus b equals 0, or 3a plus 2b equals 0. But you can't have something greater than 0 plus something else greater than 0 equal to 0. So this solution is impossible. So our solution is going to be 2a minus b equals 0, or 2a equals b. And now we'll just plug back in our a and b. So a is 3 to the power of x, so 2 times 3 to the power of x equals b, which is 2 to the power of x. Now I'm just going to divide both sides by 3 to the power of x to get 2 equals 2 to the power of x over 3 to the power of x. And using exponent properties, I can just say this is 2 over 3 to the power of x. And now, here, I'll just make this neat for you. So 2 equals 2 over 3 to the power of x. Now I want to take the log of both sides. So log of 2 equals log of 2 over 3 to the power of x. And using log properties, I can just bring the x around to make it the coefficient. So this equals x log of 2 over 3. And now I just want to divide both sides by log of 2 over 3. So I get x equals log of 2 over log of 2 over 3. Or using logarithm properties, you can simplify this even more to say log 2 over log 2 minus log 3. And that is your solution. X equals log 2 over log 2 minus log 3. Thanks for watching, and if you like my videos, like and subscribe. Thanks.